So we've looked at calculating the area between a curve and a line or another curve itself. What I want to do in this video, I'm going to set you a couple of questions based on that. I want you to pause the video, have a crack at the questions, then come back and check your answers. Here you go. So I want you to calculate the area between the pairs of curves below. So the first one is the line y equals 2x and the curve y equals 8x minus x squared. And the second one is y equals x cubed minus 2x squared minus 6x plus 4. And the line y equals 2x plus 4. So pause the video and have a go. So the first one, straight line y equals 2x and the curve y equals 8x minus x squared. First thing to do in a scenario like this is always think about how it looks, so draw yourself a sketch. So do yourself a simple set of x and y axes and draw it on just so you know what it roughly looks like. Now this curve here, 8x minus x squared, if I factorise out the x, I get 8 minus x there as well. So I've got x and 8 minus x, so I know the roots are at 0 and 8. So it's going to be a curve that looks something like that. There's my 0 and there's my 8 in my scenario there. The second one, y equals 2x, so straight line, gradient of 2 going through the origin. So it's going to look something like that. So I know the area between the two curves I'm calculating is this one here. That there's the area I want. So what I need, points of intersection for my limits, then calculate the integral. For the points of intersection, set them equal to each other. So I've got 8x minus x squared equals 2x. Shift it over and solve it and I get 6x minus x squared equals 0. Factorise it with a common factor and you get x bracket 6 minus x equals 0, and that gives me my two roots. I get x equals 0 from this one and I get x equals 6 from this one. So I know then this is going to be 0 and this bit here is 6. So that is the limits of my integral. Now if I take the negative x squared curve as being my f of x and my straight line as being my g of x, I know for the integral it's going to be between those two limits, so 0 to 6, and it's going to be upper curve take away lower curve. So my f of x take away the g of x. This I know is my f, this I know is my g, so it's going to be 8x minus x squared take away the 2x. Integrating all of that dx with respect to x. Simplify it first and you get integral from 0 to 6 of 6x minus x squared dx. Then we just integrate it as normal. Integrate it, substitute in the limits, I get my area. That gives me 6x squared over 2, take away x cubed over 3 between 0 and 6. Plug in your two limits, upper take away lower, and you'll get what you're after. So I get 6 times 6 squared over 2, take away 6 cubed over 3 for the upper limit, and then the lower is 6 times 0 squared over 2, take away 0 cubed over 3 for my lower. That's all 0, that all goes. So all I need to focus on is the upper limit here. 6 times 6 squared, well 6 divided by 2 is 3, 6 squared is 36, 3 36's give me 108. Take away 6 cubed divided by 3, what that ends up giving me is 216 divided by 3, which simplifies down to 72. 108 take away the 72 gives me my final answer of 36 square units. So there you go, that's me got my area between these two curves here. Second one was the curve y equals x cubed minus 2x squared minus 6x plus 4 and y equals 2x plus 4. Now again, first thing you should really do is think about the scenario and how it looks. So drawing a rough sketch of this one here, the x cubed curve is going to look something like this. Comes up this way, cuts through the axis there, down below and up. And my line 2x plus 4 is going to cut through the same point there, same point here, and then they're going to intersect again up there. So what I need to do is I need to find 3 points of intersection this time, and using those I'm going to be able to integrate my function. So to find the 3 points of intersection, set them equal to each other. So I've got x cubed minus 2x squared minus 6x plus 4 equals 2x plus 4. Switch it all over here and set it equal to 0. I get x cubed minus 2x squared minus 8x. Then the 4 and this 4 cancel because this becomes a minus 4 equals 0. Factorise the whole lot. I get x bracket x squared minus 2x minus 8 equal to 0. So I get x bracket x minus 4 x plus 2 equals 0. So from that, I know my three roots, my three meeting points are going to be at x equals negative 2, 0, and 4. So I know there is negative 2. This point here, x is at 0, so it's on the y-axis. And this one here, x is equal to 4. Now, as we said, when curves cross each other like this, we have to always bear in mind its top take away the bottom. Upper curve minus the lower curve. So if I call my x cubed the f of x, and I call the straight line the g of x, I know for this first section, it's going to be f of x take away g of x, so this one subtract that one. But for the second section, it's going to be g of x take away the f of x, because the g of x is now the upper limit. So I'm going to have to do two integrals here. I'm going to have to do the integral from negative 2 to 0 of the f minus g. So my x cubed minus 2x squared minus 6x plus 4 take away the 2x plus 4 with respect to x, so dx. And then I'm going to have to do a second integral from 0 to 4. But this time, it's the straight line take away the curve. So this time it's going to be 2x plus 4 take away the curve x cubed minus 2x squared minus 6x plus 4, again with respect to x. Once I do the pair of these, I add up my answers. It's total the area and I'm there. Right, first one, simplify what's in the integral. So I get the integral from negative 2 to 0. Well, it simplifies down to this. X cubed minus 2x squared minus 8x, all with respect to x, so dx. Integrating this, that gives me x to the 4 over 4. Take away 2 times x cubed over 3. Take away 8 times x squared over 2 between negative 2 and 0. Now every term here has an x in it, so if I substitute 0 into here, I'm actually going to end up with 0. So my upper part of my limit is going to be 0. So then I'm going to be take away all of this at negative 2. So it's going to be take away negative 2 to the power of 4 over 4. Take away 2 times negative 2 cubed over 3. Take away 8 times negative 2 squared over 2. So that's going to give me 0 take away, well, negative 2 to the power of 4 divided by 4 simplifies down to negative 2 squared, which gives me 4. Take away, well, 2 times negative 2 cubed. Negative 2 cubed is negative 8, so that's negative 16. So it's minus minus, so that then becomes plus 16 over 3. I've then got negative 2 squared here gives me 4. Divided by 2 gives me 2. So then going to be take away 16. So 0 take away all of this. So 4 take away 16 is negative 12. I've then got 16 over 3 take away 12. Well, 12 can become 36 over 3. That gives me negative 20 over 3. But remember, it's 0 take away negative 20 over 3. So that's 20 over 3 for my upper part. My lower part is given by this one. So again, simplify the integral to start. So it's the integral from 0 to 4 of this integral here. So 2x plus 4 take away the upper one. But essentially, you get the reversed sign version of that. So instead of x cubed minus 2x squared minus 8x, you get negative x cubed plus 2x squared plus 8x. Again, all with respect to x. Integrate it. We get negative x to the 4 over 4 plus 2x cubed over 3 plus 8x squared over 2, and again it's between our two limits, 0 to 4. Now we showed in this first one, at 0 we get nothing. 0 plus 0 plus 0, we get nothing. So for this one, calculate this at the upper limit of 4 and we're dancing. So I substitute in 4 to all the parts of my integral. I get negative 4 to the power of 4 over 4. Don't be mistaken, this negative's outside it, it's not with the 4. So we do 4 to the 4 and then take the negative of it. Plus 2 times 4 cubed over 3. It's then going to be take away the final part of it, which is given by 8 times 4 squared over 2. So calculate each little part of this. So negative 4 to the 4 over 4. Well, that ends up giving me the same as 4 cubed, because one of the 4's cancels out. 4 cubed, 16 times 4 is 64. So I get negative 64 there. I've then got 2 times 4 cubed. Well, 4 cubed is 64. 2 of those is 128, so it's then plus 128 over 3. It's then plus 8 times 4 squared divided by 2. Well, 4 squared is 16, divided by 2 is 8. 8 8s are 64. What I then get is negative 64 and the 64 cancel, and I get an area there of 128 over 3. So I've got my first area, 20 over 3. I've got my second, 128 over 3. Add them. So my total area is equal to 20 over 3 plus 128 over 3. That's equal to 148 divided by 3. And that's units squared. So when we're calculating the total area like this, it's important we remember to do that. So lower part first, taking the top minus the bottom. Upper section here, top minus the bottom. Remember it switches here, so we have to turn that round. We have to get it between the correct limits for each of the sections.